Question 4. A function f is defined by fx is equal to 2x minus 1 over x plus 1, where x is an element of real numbers and x cannot equal -1. Part A asks, the graph of y equals fx has a vertical asymptote and a horizontal asymptote. Write down the equation of part 1, the vertical asymptote, and part 2, the horizontal asymptote. Okay, so for the vertical asymptote, this will always be in the form of x equals a number. And you'll find quite often that this is given in the first line of the question, okay? Which here we're told we've got x cannot equal -1. Now, the reason why x can't equal -1 is if we were to put that x equals -1 into the denominator here, we would get 0. And we can't divide by 0 because then our function is undefined. Okay, so that is a bit of a hard and fast rule that you can take. So the vertical asymptote here is going to be x is equal to -1. We will copy this down and we'll do all the working. It's on the next page here, so we'll do it down there. Now, the horizontal asymptote for these functions, which they're called rational functions, and I'll give you their form as well. So the form of rational functions are ax plus b over cx plus d. All right, and so that's essentially what we have for f here. And we will write the horizontal asymptote as the limit as x tends to positive and negative infinity of fx. Now, I know that might not mean an awful lot yet, but I will explain that as we go down. All right, so let me get rid of this here. Let's come down. So I'll write a bit of a note in blue, so you wouldn't have to write the blue bit here in your exam, but the red bit that I write will be the kind of the answer. All right, the answer plus the working. All right, so for any rational function, fx is equal to, I think I just copied here. Yeah, ax plus b, it's made a little small, ax plus b over cx plus d. Our vertical asymptote is x is equal to d over c. Sorry, negative d over c. Okay, and you'll see that this is essentially the value of x that makes the denominator equal to 0. And so equally, so for the horizontal asymptote, is y is equal to negative a, sorry, what am I doing? Not negative, just a over c. So effectively the coefficients of x divided by each other. So yeah, a over c. So if we were to write our answers in here, so first of all we're asked to put in the vertical asymptote. So let's just write this. We'll go vertical asymptote is style red, right? X is equal to -1. And yeah, as I said earlier, quite often this is given to you in the first sentence of the question, of these types of question. So yeah, look out for that. And then now this idea here, okay, so the horizontal asymptote. So now you can just use this formula here and you'll see that it's 2 and 1. I do want to sort of illustrate this idea or expand on this idea of the limit as x tends to positive or negative infinity. So if we write that down here, limit as x tends to positive and negative infinity of, what do we have, 2x minus 1 over x plus 1, what we end up getting is two lots of plus and minus infinity minus 1 over plus or minus infinity plus 1. Okay, now the minus 1 on the top and the plus 1 on the bottom will, considering we're working with infinity here, will do very little to the value of this limit. Okay, so specifically all we're going to be looking at is the coefficients of x, or the coefficients of positive and negative infinity. And so what we're going to say is that this is equal to 2. Okay, because effectively this cancels out with this, all right? And the negative 1 plus 1, they basically make no effect, all right? So then therefore, what we're going to say, therefore, the horizontal asymptote, I'm just going to copy this. Oh, what have I done? Brought the y over. Let's make that into red, is y is equal to 2. All right, and so there is the answer for part A. And this idea here for the limit, the reason why I wanted to expand on that idea is this is going to help quite a bit for this next part, so part B, okay, for when we get to sketching the graph. All right, so yeah, going up to part B, we are asked, on the set of axes below, sketch the graph of y equals fx. I'm just going to put equals to 2 here as well. So we got that. Okay, so how about so first of all, let's draw in the asymptotes we have, okay? And we'll do that with a dotted line. So here is, oh, that's not perfect, is it? But we'll line it up. And so that is the equation of the vertical asymptote there. Yeah, I don't think this photocopy was taken straight, but that's all right. Okay, cool. So we got that there. And then also the equation of the horizontal asymptote is going to be y is equal to 2. Right, and so there we have the two asymptotes drawn. Okay. Though for this question here, we're going to need, so we're saying on your sketch, clearly indicate the asymptotes. So we've got that here. The asymptotes, but equally, and the position of any points of intersection with the axes. We'll just get intersection with the axes. We'll also indicate there. All right. So let's go back down to our working page, and we'll talk a little bit about the how to find the x-intercept and the y-intercept for these rational functions. So I'm going to copy this for any rational function idea here. Let's bring this down. So for any rational function, the x-intercept is going to be as follows, okay, is negative b over a comma 0. And hold on, let's bring this over to here, make it a little smaller. And the y-intercept is going to be when x is equal to 0, and then b over d. Okay, and there you have it. And you can also, if you forget this, the x-intercept is when the function or y is equal to 0, so you can go through and just sort of solve that. Okay, and the y-intercept is when x is equal to 0. And then just expanding a little bit on the idea of the x-intercept when the function is equal to 0. When you're trying to find that, all you're concerned about is making the numerator equal to 0, because it doesn't matter what you divide 0 by, it's always 0. So yeah, 0 divided by anything is always going to be equal to 0. That's all we would be concerned about there. Okay, cool. So then in terms of our question here, we got x. The x-intercept here is going to be not negative 1/2, it's going to be, what do we have? B, so yeah, -1/2, big pun, yeah. No, sorry, because we've already got -1, so it's -1. So yeah, just a half, comma 0, and the y-intercept is going to be equal to 0, comma, and then b over d, which is -1/d, which was 1, which is just -1. All right, cool. So there we have our x-intercept and y-intercept. Let's mark that on a graph here. So we got our x-intercept here of 1/2, comma 0. Okay, and then equally the y-intercept, which was 0, comma -1. And I'm just going to zoom in a little bit here. Move this guy to there and move this guy slightly over to there. Okay, cool. So there we have now the x-intercept, y-intercept, and also our asymptotes drawn. Let's just mark those. We'll say this is where y is equal to 2, and this is where x is equal to -1, for our vertical asymptote. Now, in our part B, we talked about the limits. Sorry, part two of question A. We talked about the limits as x tends to positive and negative infinity. All right, and we found that our function tends towards 2. Okay, so it goes towards this 2 idea. So as x tends towards positive infinity, our line tends towards this line y equals 2, but never quite touches it. Okay, so it never touches it, but it tends towards that value. Okay, equally, we know as x tends towards negative infinity, so going this way, our line is going to come down, it's going to tend towards this line here. That wasn't very good. Tend towards y is equal to 2, but it won't ever touch that line. Okay, so that gives us a little bit of an indication, or a bit of help as to the shape of our graph. And so we know on the positive side of x, okay, as x increases there, we want our line going towards the line of y equals 2, and equally on the other side, we want our line when it goes to, as x tends to negative infinity, we want our graph tending towards this line of y is equal to 2. All right, and so then when we think about that, this bottom bit is going to, so we've got to go through our y-intercept and x-intercept. And so we'll get a line somewhat similar to this here. Okay, and then as x increases, this line gets closer and closer to y is equal to 2, but never touches it. Equally, as y gets, as y tends towards negative infinity, or as x tends towards -1, all right, we know that our graph, our function tends towards negative infinity. Okay, and then now we go up to the top, and so we also know that on this negative side, okay, so around here, we need our graph tending towards y is equal to 2, but never quite touching it. All right, and so then we get this idea here, where we come through and we go out like this. All right, and then there we have our graph, okay, of fx, of y is equal to fx. And yeah, that should suffice for part B. Okay, let's move on. Part C asks, hence solve the inequality. 0 is less than 2x minus 1 over x plus 1, which is less than 2. Okay, so if we look at our graph here, we need to find when our function fx, because this expression here is just fx. So going up to our graph, we've got to find when is the value of fx between 0 and 2. Okay, and we can specifically see that is from this point onwards here. Okay, yeah, so from the x-intercept onwards, all right? And we know that since we found the limit, that fx will never touch, it will never get 2, y is equal to 2. So simply the answer, or the solving this inequality, is just x needs to be more than a half, right? And so we can write that down here and say 4, 0, and then we'll say, what's it, 2x plus 1. Oh, wait, it was minus 1, wasn't it? 2x minus 1 over x plus 1 less than 2. X must always be more than a half. And there is the answer to part C.